So welcome to this session. We are going to prove another triple product formula given that A, B, and C are vectors. Show that if I have A cross B cross C, but then the same thing as B cross A, B times A dot C minus C A dot B. So remember, to prove an identity, show that the result for the left-hand side is the same as the result for the right-hand side. So one way to do this, we can reduce the right-hand side, get a value, and then also reduce the left-hand side, get a value, and then compare the two to see whether they're the same. So the proof, let A be given by A1I plus A2J plus A3K, B be given by B1I plus B2J plus B3K, and C be given by C1I, C2J, C3K. So let those be the three vectors. So we want to simplify the left-hand side. So left-hand side, we have A cross B cross C. So the same as A1I plus A2J plus A3K. You cross with, so this one we have IJK, and so we have B1, B2, B3, C1, C2, C3. So which will be now, this part will have A1I plus A2J plus A3K. We are crossing this with, so as usual, this determinant, we use expansion by cofactors. So this one has positive sign, so we'll have close this and this one, so we have B2C3 minus B3C2, and then I minus J into close this and this, so we have B1C3 minus B3C1 plus, okay, so I'll have K into close this row, close this column, B1C2 minus B2C1. So that's step 2. And so this can be written as now a determinant IJ j, k. Now here we have A1, A2, A3, and then this will be B2, C3 minus B3, C2. And then this one now, opening, this will be plus, this negative, so I have B3, C1 minus B1, C3. This other one will be B1, C2 minus B2, C1. That's what we have. So this, we get its determinant in the usual way by cofactor expansion. So this plus, this minus, this plus. So we'll have I times, so A2 into brackets B1, C2 minus B2, C1 negative. So remember, close this and this one here. So we have this A3 into B3, C1 minus B1, C3. And then minus J into close this, we have A1 into B1, C2 minus B2, C1 minus A3. Remember, we close this one and this one here. So A3 into B2, C3 minus B3, C2. And then plus K, then close this and this. So we have K into, so this and this deleting. So we have A1 into B3, C1 minus B1, C3 minus A2 into B2, C3 minus B3, C2. Remember, we are closing this, this one and this one here. So this, then this one here. So IE, left-hand side, will be A cross B cross C, will give us, so we have A2, B1, C2 minus A2, B2, C1 minus A3, B3, C1 plus A3, B1, C3I, and then J can make it positive by now starting this term. So say plus. So this will be A3, B2, C3. And then, so remember this word multiply this plus. So minus A3, B3, C2. Now minus A1, B1, C2 minus A1 plus now A1, B2, C1 course, this now negative, so this will be plus. J, and then plus, lastly, A1, B3, C1, minus A1, B1, C3, minus A2, B2, C3, plus A2, B3, C2. This is K. So that's what you have. And then, so left, right hand side, we'll have B multiplied by A dot C, and then minus C multiplied by A dot B. So vector B is B1 I plus B2 J plus B3 K. So I'm multiplying by, so A dot C is simply A1 C1 plus A2 C2 plus A3 C3. That's by definition of dot product, minus C1I plus C2J plus C3K. And then this we multiply by A dot B. We have A1 B1 plus A2 B2 plus A3 B3. That's just by definition of dot product. So these are just a constant, so it multiplies every component. So here we'll have A1 B1 C1 plus A2 B1 C2, then this multiplied by this, plus A3 B1 C3. So this will be the I component here. And then plus, so we have B, so we have A1 B2 C1 plus, so B and this, so we have A2 B2 C2 plus A3 B2 C3 J, and then plus, so this one now B3, so A1 B3 C1 plus this time this, we have A2 B2 and then C3 plus A3 B3 B3K minus, so this we are multiplying by every term here. So we'll have A1 B1 C1 and then plus this by this one here, I have A2 B2 C1 plus this by this, I'll have A3 B3 C1. So I minus J, I'll have now C2 multiplied by this. So I have A1 B1 C2 plus A2 B2, C2 plus A3, B3, C2. This will be J, a negative A1, B1, C3 plus this by this will have A1, A2, B2, C3 plus this by this will give me A3, C3, B3, and then C3. So have this A3, B3, C3, then this is K. Just now collect like terms, like vectors. So vector I together, J is together, and then K is together. So we'll have I, this one is A1, B1, C1 plus A2, B1, C2 plus A3, B1, C3 minus, so this will be everything negative. So A1, B1, C1 minus A2, B2, C1 minus A3, B3, C1. So this is I plus, for J, I'll have A1, this one here, B2, C1 plus A2, B2, C2 plus A3, B3, C3. And then all these ones, they are negatives. So negative A1, B1, C2 minus A2, B2, C2 minus A3, B3, C2, J, then plus for K, have this as A1, B3, C1 plus A2, B3, B2, so this one here, C3 plus A3, B3, C3, and then all these are negatives, negative A1, B1, C3 plus A2, B2, C3, this minus because there's negative outside here. That's why this one, B2. We have this B2, so this negative, and then A3, B3, C3, then K. So within this bracket, some terms will cancel out. So this and this, this and this, this and this. So that now we'll have the answer finally now will be right hand side will give us A2, B1, C2 plus A3, B1, C3 minus A2, B2, C1 minus A3, B3, C1 I plus, for J will have A1, B2, C1 plus A3, B3, C3 minus A1, B1, C2 minus A3, B3, C2, and then plus A1, B3, C1, plus A2, B2, C3, and then minus minus A1, B1, C3, minus A2, B2, C3. Okay. So that's so A2, B1, then C2 plus A3, B1, C3 minus A2, B2, C1 minus A3, B3, then C1. And so if you compare this solution and the solution we got for the left-hand side here, then those two solutions are actually the same. This solution, so this solution for left-hand side and right-hand side. So left-hand side equals to right-hand side, and therefore that's the proof that given relationship. So thank you.